In the part 2 of the video, we will demonstrate the use of the ATS7308 user interface. So we're going to click to open the executable. We're going to start with the tab 1, which is the array configuration, and you go into details of all the options available. The input and the output directory is the first two lines, so you define where you want to input the data, where it's located. So in my case, it's located in the directory antenna input, as you can see here, antenna input, and the output is defined at the antenna output. So that's the output. So we have a measurement file that's taking a measurement directly from the beamforming ASIC and gives the corrected, in the particular case, the corrected control word. So there are different, so the configuration itself of the array is done with these options. So you see, for example, the first option is the number of elements in X, it's 8. So the ATS unit supports 8 elements and 1 in the Y direction. So it's a linear array. You can define the levels of side lobes, X and Y. So you have a uniform 0 dB and the level of suppression 34 degrees. Of course, it depends on the size of the array. In this particular case, I will keep it on the 40 dB using a window function that is predefined with the software. It's a Dov-Chebyshev window function. There are other controls of elevation azimuth. You can add also imbalance. In this particular case, it's all 0. There is some other options here that is define isolation, that you can go a little bit in more details about the impairments of the array. But let's go with the additional configurations. You have grouping elements. For example, if instead of have half wavelength space in between the elements, you want to group two elements having the same phase, so it gives a wavelength. So you can actually group some of the elements in the X and Y direction. The number of users, you may want to have more than one user, and the elevation for each of the users that you want to look at. So 30 minus 30, you can actually define that elevation. The antenna gain, this sets a 6 dB, that's a parameter. And you have also, for example, for some particular configurations, the nulls and direction of arrival, so when you want some of the options. So these are the options you can adjust into the array. On the right hand side, there's the array configuration, so you can choose between a grid, triangular or square grid, no steering, orthogonal, planar, couple, and can actually have an option that is loading the coupling matrix. So it's going to take this complex matrix and actually load into the design. And there's an option here to generate a JSON file and allow the ATS to be controlled externally with another computer in the network. So these are the control modes and for the arrays. And there's some also additional features like a recalculate A word. So basically it's all the amplitude imbalance on the array and actually optimize the imbalance in providing the pattern in the array. So that you can actually recalculate the word. So it takes the control word and it recalculate and optimize for the array, particularly looking at the amplitude. There is a check model, so you basically do a model check for the beamforming. You press a load measurement, so basically it's going to load this measurement. So if you want to press the load measurement, if you leave it unpressed, then it's going to just consider an ideal sweep. So then you can take this option. You can have plot the pattern, so whatever you configure into the display, you can actually plot the pattern, and you can save the output file. Basically what it's going to do is saves the array file containing the individual control word for the different arrays. So let's do an example in this 8.1 here. So you just press, let's set at 30 degrees, for example. So I set here at 30 degrees. And I'll just keep everything on default. I won't change anything at the moment. And then I'm going to press load. So basically here is steering the array at the 30 degrees and using Dov-Chebyshev 40 dB suppression. So this is one option. So if you want to make the plot to save, so I can use 8 by 8. This is a rectangular array, a very standard in communication. So I can put an 8 by 8. And then let's say an example in this particular case that I want to look the output files when I save the option. So let's run again. So this is the array, and let's look at the output words that have been created. So I'm gonna date modify it. Latest word, this is at 8 by 8 here that is generated right now. It's 10:30 p.m. So I'm gonna double click to inspect this file, and it actually already generated the control word of the array. So everything is here. So this is the control word, the first two MSBs. This is the amplitude settings, and these here are the phase settings for the array that you want to configure, for example, in a 808 configuration.